And now we're going to look at standardized data. This lesson is short and sweet, so we have one goal and one goal only: convert raw scores to standard scores and vice versa. Go ahead and please write down what you see in this green box as I explain. A raw score is the actual score, meaning if you got, let's say, an 82 points on a test, that would be your actual score. When we're talking about raw scores, we don't talk about the total, like 82 out of 100. We just talk about the points you earned. Standard scores, which are also known as z-scores, are a little different. That is a general score that compares to others. So basically, it is a quick way to tell you and tell others, did you score average compared to others, or above or below average? So let's take a look at this diagram and a little more information here so you can really understand how z-scores work. To determine how unusual a data value is in comparison to the average, each data value is assigned a score called the z-score. These are your z-scores right here. A z-score counts the number of standard deviations that a data value is from the mean. Remember, the mean is the average. It's always right in the middle with a z-score of 0. So, and each standard deviation are these lines you see here. A z-score is a decimal value that ranges from just below -3 to just above +3. Notice you see +3 way over here, -3 way over there. And it's difficult to see on this diagram, but remember, there is a little tiny sliver outside there and there for the extremely rare cases. A z-score of -3 is also extremely rare and unusual. Of course, on the negative side, that's below average. On the positive side, above average. Okay, so that's how z-scores work. They're also called standard scores. So let's imagine for a second your friend comes up to you and tells you, hey, I got 38 points on my test today. And that's all they say. Would you know how well they did? No, right? Out of how many points? I have no idea. I need more information to go off of. But with a z-score, if that same friend came up to you and says, hey, I got a z-score of 2, would you know then? You would, right? Now that you've learned about z-scores, you know +2 is above average. That is a really good score. You'd be congratulating them, right? And let's talk about standard deviation. Again, as a reminder, standard deviations are these vertical lines. So +1, that's 1 standard deviation away. If you go 2 over, that's 2 standard deviations away in the positive direction. And then, of course, there's also the negative direction. Okay? So the standard deviations very, very closely correlate to the z-scores. And you will get z-scores that are decimals. You don't see any here, but that will happen, and you will see that very soon. But now you need to write down the z-score formula. It's over here. This is what we use to find z-scores. Please get familiar with all of these elements. Z stands for z-score. X is the actual score, aka raw score. Mu is the mean, and sigma is standard deviation. So to find the z-score, you need all 3 parts of this information. And let's, for a moment, imagine that your raw score, which symbol symbolizes that? X. Your raw score, let's say, is the same as the mean. Which symbol is that? Look in the formula. So right here, we're talking about these 2 formulas. If those are the same value, what's going to happen? Well, the numerator will become 0, making the entire fraction 0. So that means you scored perfectly average, right in the middle, z-score of 0. Which makes sense, right? If your score is the same as the mean, that's what happens. Okay, so let's take that information and just get a little more comfortable using this formula before you do it for yourself. The data set is normally distributed with a mean of 30. How nice of them to give us the symbol there as well. That is rare. And a standard deviation of 4. Again, symbol there. What are the z-scores for 38, 26, and 20? I'm only going to look at solving for the z-score of 38. I'll say that differently. We're going to find the z-score for the raw score of 38. So raw score of 38, well, raw score goes there, so 38 there. Then we have the mean minus the mean, so that goes there. Over the standard deviation, that goes there. Subtract, divide, you get 2. So really today is about understanding what a raw score is, a z-score, and then using these formulas, which definitely requires getting used to these symbols. And right here, check it out. You see that z-score as a decimal, like I mentioned a moment ago. Now it's time for you to practice. Suppose a normal distribution has a mean of 20, standard deviation of 4. They want to know the z-score if the raw score is 22. Give it a try. Okay, we know we need our z-score formula. We have our raw score, they told us, 22 minus the mean, which they also told us, over the standard deviation, which they also told us, subtract, divide, you get 1/2. But you always see z-scores as decimals if there are decimals. You're not going to see fractions. Now, remember in our goals, we are aiming to convert raw scores to standard scores and vice versa. Well, here's your vice versa, solving for the raw score. Of course, then you're going to need all of these 3 parts of information. Write this down. It's a different formula to find something different, which is the raw score. Okay, so let's use this formula to help Ray determine, is he healthy or does he need to make some lifestyle changes? Convert the indicated z-score to a raw score. Before we read anything else, we already know we're going to use our raw score formula. There it is. The systolic blood pressure given in millimeters of adult males in a population is normally distributed, so we can use this diagram to help us, with a mean of 125. Might as well label it here. Okay. And a standard deviation of 15. Ray is told his blood pressure has a z-score of 3. What's his actual blood pressure? Before we do any work, we can already help Ray understand if he's healthy or not based off our understanding of z-scores. What do you think? Is he healthy? Can you find a z-score of +3? Well, it's way over here. That is exceptionally high. Exceptionally high. Okay, on a test, an exceptionally high z-score is a great thing, right? But if you know anything about blood pressure, exceptionally high is very bad. He needs to make some lifestyle changes pronto. Okay, so let's use the formula to let him know what his actual blood pressure score is. We have the mean 125 plus, what do we need? Z-score of 3. Sorry, that should be plus. And then standard deviation of 15. PEMDAS to multiply and then add raw score of 170. And that makes sense. If you look at your standard deviations, every time you go to the right, you add 15. Now let's move that over a little bit. So 140, 155, and then this would be 170. Formula works. Amazing. And we are all ready to our exit ticket. I told you this lesson will be short and sweet. So practice one more time, and then we'll work it out together. Here we go. Convert the indicated Z-score to a raw score. Right away, raw score formula. A college professor establishes the cutoff Z-score of -2.5 for passing an exam. If a student's Z-score is below -2.5, the student fails. But if it's above -2.5, the student passes. On an exam in which the scores are normally distributed with a mean of 74 and a standard deviation of 8, what is the cutoff raw score? They want to know the cutoff raw score, and we were given the cutoff Z-score, so we can do that. Before we do, just think about this logistically. Is this professor being kind or harsh? Well, a Z-score of -2.5 is way down here. He's saying anyone who scores above that will pass. I'd say he's being generous. So now that we understand that, let's work it out. We have our mean, our Z-score. Use parentheses, don't get your signs mixed up, times the standard deviation. So we multiply and we add to get 74 minus 20, subtract. Answer is D. And that's it for today. Practice, practice. So you get these formulas embedded in your minds as well as these symbols. These are key to understanding this lesson. See you next time.